This is section 4.1a notes. This is kind of introduce what a system of equations is. The things you're going to do in this section is solve a simultaneous linear equation by graphing. Those are also called systems. Understand what it means to solve a system of equations. Identify and provide examples of systems of equations that have one solution, infinitely many solutions, or no solutions. And you're going to be able to tell me what the solution means in a context. All right, so here's what I want you to do. I want you to actually stop the video and fill in, and then look at the examples I gave you. So the Student Council is planning a bake sale to raise money for a local food pantry. They are going to be making apple and peach pies. They have decided to make 10 pies total. Each pie requires 2 pounds of fruit, therefore they need a total of 20 pounds of fruit. So I want you to fill out only the first 2 columns of the table right now with 8 possible combinations of apples and peaches that will yield 20 pounds of fruit. So I only want you to do 8, but I'm going to write down a bunch of combinations so that you can check yourself. Okay, there are other combinations, but I just put down a couple options for you. You should have at least 8. Okay, letter B says 1 pound of apples costs $2 and 1 pound of peaches is 1. So this is apples are $2 a pound, peaches per pound. Peaches are $1 per pound. So now I want you to fill in the rest of the table. So for example, for the first one, if you have 0 apples, then you're not going to pay anything for them. If you have 20 peaches that are $1 per pound, you're going to pay 20, so the total is 20. So go ahead and fill in the rest of the table. Stop the video and fill in the rest of the table. Okay, so stop and check yourself and make sure you have that all filled in. So let's go to letter C. Mrs. Harper, the student council advisor, tells students they have exactly $28 to spend on fruit. How many pounds of each type of fruit should they buy so that they have the required 20 pounds of fruit and spend exactly $28? Well, we're going to go back here and we're going to look at our last column for $28. So that's right here. So that column shows 8 pounds of apples and 12 pounds of peaches. So let's go back and fill that in. 8 pounds of apples and 12 pounds of peaches. Okay? So let's go on to letter D. So if P represents the number of pounds of peaches purchased and A represents the number of pounds of apples purchased, the situation above can be modeled by these 2 equations. P plus A equals 20 and 2A plus P equals 28. And the situation meaning they have $28 to spend. So let's write what each of those equations are in words. This P plus A equals 20 is the total number of pounds of fruit. And the 2A plus P equals 28 is the total cost of the fruit because apples are $2 a pound and peaches are $1 a pound. So this is total cost of the fruit. Okay? So we said that the answer we found for part C was 8 pounds of apples, right? and 12 pounds of peaches. So what we want to see now is, do these numbers make both of those equations true? And here's how we're going to find out. So we are going to plug in 8 for A and 12 for P in each one of those. So this first one is P plus A equals 20. So we have 8 pounds of apples and 12 pounds of peaches, and 12 plus 8 is 20. So it works for the first equation. Now, let's plug in the same numbers for the second equation. 2 times 8 plus 12 equals 28. So we have 16 plus 12, and 28 is equal to 28. So both of those numbers work for both of those solutions, or both of those equations. Okay? So now let's do something really interesting. Let's graph the two. Okay? So I am going to make the apples y and the peaches x. So let's change this to x plus y equals 20. Okay? So my peaches are x, my apples are y. Let's rearrange this so we can graph this. We're going to subtract the x, so we have y equals negative x plus 20. I'm going to start here at 20, and these go by 2's. Okay? So I'm going to go down 1 over 1, down 1 over 1. So we are going to go like that, straight down. I wish they had labeled by 1s, but we're going to live with that. There we go. Okay? So now, remember, we're going to change, let's go over here, apples to y. So let's rearrange. So I have 2y equals negative 1x plus 28. I'm going to divide by 2. So I have y equals negative 1/2 x plus 14. So I'm going to start here. I'm going to go down 1 over 2. And look at this. Find the point of intersection on the graph. Where do they intersect? Right here. So the point is 12, 8. Where have you seen those numbers before? It's the same as these solution that we highlighted here. Look at 8 and 12. It's the same as the solution we found on the table. Okay? So we are going to do 2 more, and that's it. That's all we're going to do in these notes. We're going to do H and I. The bake sale problem can be modeled using a system of linear equations. Write in your own words what a system of linear equations is. What is it? Take a minute, write it down, and then I'm going to give you my answer. two or more equations working together to explain a situation. That's it. So now you need to explain in your own words what a solution to a system of equations is. Okay, so I'm going to tell you here the solution to a system, if there is one, sometimes there isn't, it's the ordered pair that satisfies both of the equations. When you're talking about a graph, it's the point of intersection of the two lines. Okay, that's all the notes we're going to do for this section. You have more, but you only need to go through I. Thanks.